Steve Benson joins us. Steve is the Associate Vice President for Research with the Energy and Environmental Research Center at the University of North Dakota. He's also a professor at the Institute for Energy Studies at the University of North Dakota. And he's joining us today because he's currently working on a project with Great River Energy to search for rare earth elements that are found in conjunction with western North Dakota's coal fields. Partially funded by the North Dakota Industrial Commission through the Lignite Research and Development Program. And that state money comes from a tax on the lignite industry. We've talked about that tax before, and now we get to talk about one of the benefits of those dollars. Steve, thanks for joining us. How are you?
Hey, I'm doing great. Thanks a lot.
What is an example of a rare earth element? What is that?
Well, there are elements like, I don't know if you only know the chemical form of them. There's lanthanum, cerium, neodymium, samarium, europium. So they have all these strange names, and they're in what's called the lanthanide series in the periodic table. If anybody's interested. So
if we're mining for coal, you take the big old drag line out there and scoop away 150 feet or so down, pulling out the coal. Is this stuff coming up with the coal?
Yeah, this stuff is actually more concentrated in some parts of the coal than and actually the associated materials or sediments that might lay the roof material and the floor material of the coal. So they seem to be concentrated in certain regions.
And what are these things used in? What kind of this byproduct? Is this a byproduct or just is it there because of the coal, or is it completely independent of the coal?
Well, the way they ended up there is probably during when the coal formed. They seemed to be from volcanic ash that it did, and then the rare earth elements ended up being leached out of that into the coal, and ended up in the coal, and that's where they are. Potentially maybe 10 times higher than what they are in the surrounding sediments.
All right, interesting. Now, what are they used for? What kind of?
Used in.
Sorry, go ahead.
A lot of the modern electronics. For example, they make magnets stronger. So in wind turbines and that sort of thing, they're used in that. They're used in all sorts of to strengthen materials. So they're used to strengthen alloys to make things stronger. They're used in catalysts. They're used in your cell phones. There are so many different applications. They're used in batteries to make the batteries last longer. They're used in fuel cells. There's numerous applications for these. So they're in a lot of the modern electronics. They are, that's where they're used most of the time. Fascinating.
So this project that you're working on with Great River Energy right now, searching for these elements, is designed to do what? What is your ultimate goal here?
Yeah, what we're doing is what we've done is we find out where these elements are concentrated in the lignite seams, and then we look for ways to recover those elements. And what we found is that in many cases we can get 85 to 90% of the elements. We can recover those from the lignite, and then you can go and concentrate those, and then they can be used in various processes.
Very interesting. So right now, are we doing anything with them as the coal is mined? Are those found now?
They're in the coal and they're in the mine. They probably end up in the ash material. We're not recovering them in North Dakota yet, but we're looking at. Right now, we're being funded to identify where the rare earth elements are, come up with ways to effectively remove those, and then develop processes to recover those. And the project with Great River Energy is co-funded by the Department of Energy and North American Coal. So there's several players in this, and we've been very successful recently in our ability to recover these elements.
Interesting. So it's a question of the use. The actual product itself, this rare earth element, obviously has some value. Now it's a question of how much of it and how do you capture it. to make it profitable that you're trying to answer, it sounds like.
Yeah, that's exactly what we're working on.
And what are these elements now? How are they recovered now? Are they? I mean, is there separate mining just for those elements to pull these out and use them for the products you mentioned earlier?
Yeah, there's some. These elements are usually kind of evenly distributed in the crustal material of the earth, but there's certain minerals that they are concentrated in, and there's only in the United States there's only like one or two places in the United States where they're recovered. And the challenge that we have is basically a national security challenge, because 85 to 90% of the rare earth elements produced in the world are outside of the United States. So it's a security challenge, and probably 80% of them are from China. And if the resources from China are not available, that's a big challenge.
Very interesting. Well, sounds fascinating, and what a great investment, obviously, on behalf of the North Dakota Industrial Commission and the Lignite Research and Development Program, to dig into this and find out if there might be, again, more use for the good work already going on in our lignite industry. Fascinating. Steve, thanks for the update. We appreciate it.
You bet. Thank you.